Hi, Assalamualaikum to Madam Norleha. Today, me and my friend, our group, will present to you about our project, which is flexible electronics material, designing a bendable and stretchable circuits, presented by Group 6. Okay, now I will introduce our team member, which is Muhammad Shukri, Muhammad Iqbal Shakir, Isfahan, Nur Elisha, and me myself, Muhammad Syamil. For our introduction in our topic, which is designing a bendable and stretchable circuit, we chose graphene as our material to design the stretchable and bendable circuit because of its properties and also what is graphene. Graphene is a single layers of in the it's a single layer carbon atoms, and the properties are very excellent at conducting electricity, thermal resistance, and stronger than steel. And also, the most important is it can stretch up to 20%. Okay, for our background in graphene, we will go to the origin, from where it is come from, and why is it important to discover this material, and what is the benefit. So first, we can say that it is founded at University of Manchester, UK by Game and Novoselov in 2004. Graphene is actually a atomically thin carbon material made up from hexagonal arranged carbon atoms. And why 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 the discovery, why it is important in our current time, is because of the limitations and challenges of the current circuit. One of it is thermal issues, large size, and performance capability. So graphene actually have a good electrical conductor, better than silicon, that which is enables efficient change transfer. And graphene also have high thermal resistance, which is can counter the thermal issues from circuit nowadays, so that the circuit system can be more efficient without overheating. And last one is, since graphene can be easily stretchable and bendable, so it can help solve the problem of large size of this current circuit nowadays. Okay, now I will pass to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Isfahan bin Yulia. So I'll be further continuing on our presentation. So as for my part, I will be presenting on details, types of materials chosen, and its structure. So as for our topic on flexible electronic materials for bendable and stretchable circuits, we decided to choose a graphene as our materials. And the graphene that we consider has three types. Basically, we choose monolayer graphene, few layer graphene FLG, and graphene composite. Okay, so now we are continuing on the types of the structure of the types of the graphene that we chose earlier. So this is basically the structure of the monolayer graphene. So basically, it's just a single layer of carbon atoms in a 2D honeycomb lattice, as we can see from the picture, right? We can see from the picture here. Basically, it's just a single layer, right? So that's why, hence, it is called monolayer. Monolayer of carbon atoms or graphene in a as if in the form of beehive or a honeycomb, right? Now, secondly, on the second type of the types of material and the structure of graphene that we chose, that we consider is basically a few layer graphene, which is uh, which the abbreviate stands as FLG. So basically, its structure consists of about 2 to 10 layers of graphene, right? It could not consist around like less than two, because that would consider it as a monolayer graphene, right? So usually few layer graphene would consist about 2 to 10 layers of graphene. As you can see from the picture here, so we have uh, multiple layers of graphene, right? Multiple layers of monolayers graphene, as you can see. So this is the third structure for graphene, which is called a graphene composite. Why it is called composite is because the graphene is actually combined with materials like polymers, metals, or ceramics in order to achieve a desirable mechanical properties, right? For example, like maybe we wanted to consider a graphene that has a appreciable degree of ductility, so we need to basically mix it with other material, right? So maybe we can have a for example element A, which has a mechanical properties of strong, hard, but brittle, and element B, which has a elements which has mechanical traits, sorry, or mechanical properties of soft, weak, but ductile, right? So if we combine it, maybe we get a desired mechanical properties that we are looking for. For example, if we wanted to get a properties that has a strong, uh, strong, hard, and appreciable degree of ductility. So now we are moving on to the key features of graphene. So as you can see in this slide, we have all three types of graphene that we have considered and we have discussed earlier on the previous slide. So we have monolayer graphene, few layers graphene, and also graphene composite. So as for monolayer graphene, monolayer graphene has an exceptional strength, which is about 130 GPa of tensile strength, right? So basically, this means that monolayer graphene has a very high strength mechanical properties, and it is also has a high electron mobility, which basically monolayer graphene has a trait where it has a non-localized electron. So when we are talking about non-localized electron, it is actually a conductor or conductive towards passage of electricity. Hence, why the third traits of monolayer graphene said it is an excellent electrical conductor up to 5,000 watt per meter Kelvin, and also a good thermal conductivity as a result of the non-localized electron in its atom arrangements, which means it is conductive towards passage of electricity and also conductive towards heat, right? And it also has 97.7% transparency to visible light, and also extreme flexibility. So basically, it can be bendable and stretchable in order to make a electronic circuits, right? Which is convenient for a lot of uh, you know with a lot of electronic application nowadays that need intricate details design to fit it into the machinery or circuit, electronic circuit, right? So now moving on to the few layers graphene. So few layers graphene is slightly reduced in terms of its electrical conductivity, right? But it still has an excellent electrical conductivity and flexibility compared to monolayer graphene. And it also has a good mechanical strength and also thermal conductivity. As for the graphene composite, it has a interface structure crucial for properties like strength, conductivity, and flexibility. So basically, what it means by interface is that it has a layers by layers of, basically it has alternating layers of um, elements, right? For example, since it says interface structure crucial for properties like strength, right? Maybe it has alternate layers of elements A, which has a mechanical properties of high strength, high hardness, but high brittleness, with element B, which is soft, weak, and ductile, right? So when this interface structure, right, exists in the graphic composite, um, when they combine between two elements of what I said earlier, maybe they, for example, they want a totally new um, product that has the combination of two of these elements. Maybe they want um a high strength component with high hardness component, but with appreciable degree of ductility. Since we are talking about designing a flexible electronic material, so we want a electronic components that has high strength, high hardness, but not brittle. So we want a certain degree of ductility. So that's why we wanted the alternate layers or interface structure, which is crucial for properties like strength, conductivity, and flexibility, which has enhanced mechanical strength, stretchability, and electrical conductivity, like I said earlier. And also, it can be customizable. It has a customizable property for specific applications, just like I said just now, since this is a composite, right, and it has interface. So basically, in graphene composite, we want something that can be combined with, in order to achieve a totally new element with mechanical properties that we want, right? So if we want to design electronic materials with appreciable degree of ductility, we want it to be stretchable. We want it to be bendable. So we need to consider elements that has uh, a ductile properties in the element, right? So that's all for me. Thank you.
Assalamualaikum. I am Muhammad Iqbal Shakir bin Ahmad Jalani. We'll talk about the physical properties of graphene. Graphene is a single layer of carbon atoms arranged in a hexagonal honeycomb structure. One of its amazing characteristics is it has high strength. Graphene is nearly 200 times stronger than steel, even though it's only one atom thick. This is because the carbon atoms in graphene are bonded very tightly together, making it incredibly strong and durable. Despite its strength, graphene is extremely lightweight, making it an ideal material for produce strong but lightweight items. Next, graphene has a very good electrical conductivity. Graphene can conduct electricity more efficiently than conventional materials like silicon. Electrons flow through graphene very quickly and with little resistance. This makes graphene an excellent choice for electronic components such as flexible screen sensors and transistors. Next, graphene is almost transparent because it absorbs only about 2.3% of light. This transparency makes it ideal for applications like transparent solar cells and touchscreen. Furthermore, graphene is very good heat conductor. It can transfer heat much better than materials like copper, which is often used in electronics. Graphene has high thermal conductivity because heat can pass through it very easily because of the strong bond between its carbon atom. This makes graphene very useful in applications that require efficient heat dissipation, such as cooling electronic devices. In summary, graphene is a remarkable material with a unique combination of strength, electrical conductivity, uh, transparency, and heat conductor. These properties open up a wide range of possible applications in technology and industry.
I am Hamashkri. I am going to present the next part, which is mechanical properties and microstructures of graphene. Graphene is the strongest known material, surpassing other materials like A36 structural steel, which is the strength of 400 megapascal, and Kevlar for the strength of 376 megapascal. The bond strength of graphene is derived from robust carbon bonds of 0.142 nanometer length. Graphene is also lightweight, with only 0.77 microgram per meter square, making it nearly 1,000 times lighter than a square meter of paper. The carbon atoms of graphene are arranged in a hexagonal lattice, forming a flat and two-dimensional structure. The unique properties of graphene arise from the delocalization of two p orbitals over the carbon sheet, creating a pi-state bands that contribute to its electronic and mechanical properties. That's all from my part. Thank you.
I'll be discussing the fabrication process of graphene-based electronics. This process can be broken down into three main steps: preparation of graphene, transferring process, and patterning process. Firstly, we have the preparation of graphene. This involves using chemical vapor deposition or CVD. In this technique, carbon atoms are deposited onto a substrate from a gas phase. This method is widely used due to its effectiveness in producing high-quality graphene. Next, we move to the transferring process. Once the graphene is prepared, it is transferred onto flexible substrates such as polyethylene terephthalate or polyimide. This transfer is done using methods like wet transfer or roll-to-roll processing. These flexible substrates are crucial for creating bendable and stretchable electronic devices. Finally, we have the patterning process. In this step, the graphene is patterned into circuits using lithographic techniques such as photolithography and inkjet printing. These techniques allow for precise control over the circuit design, essential for the functionality of the electronic devices. Next, I'll be covering the diverse applications of graphene-based electronics. Graphene's unique properties make it suitable for a wide range of advanced technological applications. Firstly, graphene is used in high-speed field effect transistors (FETs). Due to its exceptional electrical conductivity and thin structure, graphene allows for faster electron mobility, making FETs more efficient and high-performing. Secondly, graphene is ideal for touch panels. Its transparency and flexibility, coupled with excellent electrical conductivity, make it perfect for the touch-sensitive surfaces used in smartphones, tablets, and other touchscreen devices. Next, graphene is utilized in LEDs and photovoltaic cells. In LEDs, graphene can improve performance and energy efficiency. For photovoltaic cells, graphene enhances the efficiency of light absorption and electricity generation, contributing to better solar energy harvesting. Moving on, graphene plays a crucial role in biomedical sensors. Its high sensitivity and biocompatibility enable the development of advanced sensors for detecting biomolecules, monitoring health conditions, and diagnosing diseases. Lastly, graphene is used in triboelectric nanogenerators (TENGs). These devices convert mechanical energy into electrical energy, and graphene enhances their efficiency and durability, making them suitable for wearable technology and self-powered devices.
In conclusion, we can say that graphene material is one of the most radical enhancement we can get in our circuit industry because of its characteristic and properties that is unique and also better in a lot of ways than our current circuits. So which is better in thermal resistance, better in electricity conductivity, and also its properties that can stretch and bendable than other material of the circuit. So it is really a versatile material that can be used in other industries such as medical industries, and also uh, and also in industry that requires a particular technology that is uh, that is required the properties of graphene. And also from that we can say that graphene also is a good materials because of the sustainable sustainable approachment in our future. So for our future. So uh, that's all from me and my group. Thank you.